All right, so moving on to question 3. With each question here, we're kind of getting something different. So for this question, you'll notice that the new kind of situation that we have to deal with is that this isn't really simplified and ready for us to start on step 1 yet. So the problem that we're working with is square root 2 times the cosine of x minus 3 pi over 4 plus 1 is equal to 0, and our interval is any x value should fall between 0 and 6 pi. So I've written out our five steps here, but I've also added this kind of little like added note at the top, just to remember you always want to start off with a simplified equation where it's just cosine of your argument, which is like cosine of an angle equals. That's the simplified version of trig equations, is where it's just cosine, whatever in the parentheses, an equal sign, and a value. So that's what we're going to work with for simplifying in our equation. That's what we're going to try to get to first of all. So I'm just going to write over here, before we get to step 1, we're going to simplify. That's our where we're starting with for this equation. So I'm going to copy it down. Square root 2 cosine x 3 pi over 4 plus 1 is equal to 0. So this is going to be kind of like throwing back to algebra. So the first thing that you would do here is take care of this plus 1 and subtract that from both sides. I'm going to draw a line here so you can kind of see. And you get square root 2 cosine x of 3 pi over 4 is equal to -1 because you're subtracting 1 from 0. And then next, you would take care of the square root 2. So to do that, you'll divide this whole term by square root 2, divide this side by square root 2, and these will cancel out. So you're just left with cosine of x minus 3 pi over 4 is equal to -1 over square root 2. Now this should be kind of like, should have like fire or alarms going off in your head, red lights flashing, because you have a square root in your denominator, and we talked about that when we were talking about unit circle triangles, that we want to rationalize our denominator to get rid of square root. And to do that, as you may remember, you're going to take your -1 over the square root of 2, and you're going to multiply by square root 2 over square root 2, because that's really like multiplying by 1. But when you do so, it's like squaring the square root of 2, which those two things cancel out, and you're just left with 2. And for our numerator, we're going to do -1 times the square root of 2, which leaves us with negative square root 2 over 2. So then our final simplified version of our problem here turns out like this. Cosine of x minus 3 pi over 4 is equal to -2 over 2. That's in our simplest version for trig equations, where you just have your function, then you have whatever is representing your angle measure in your parentheses, an equal sign, and a value. So looking at this question, for step 1, now that we have it simplified, we can move on to our regular steps that we're used to. Identify our argument and our interval. We have an argument, that's whatever in your parentheses, that's whatever representing your angle measure. So for this, our argument is x minus 3 pi over 4. and our interval, going way back up at the top here, is 0 is less than or equal to x, which is less than or equal to 6x. We kind of have a big interval here for this one that we're working with. Okay, so now we have that. Move on to step 2, which is identify our unit circle reference angles. So for this one, for the last two equations, we've been working with sine. For this one, we're working with cosine. So when we're looking at our unit circle, we're no longer going to be looking at each of the y values. Now we're looking at the x values, because when you're looking at our our unit circle, ordered pairs, we're looking at our x values, which represent our sine value, our cosine values. Our x values on our unit circle and our ordered pairs represent the cosine value of that angle. Okay, sorry about that. So for looking at this, we're looking at whatever cosine values, we're looking at for what angles cosine here is equal to -2/2. So for what values on our unit circle does cosine equal -2/2? So we know that cosine is our x value in our ordered pair, so we're going to be looking wherever x is going to be negative, which when we're looking on our x-axis, we know that x is going to be negative on this side. So we're going to be looking at the cosine values on this half of the unit circle. So we're going down. Oh, here we are. Negative square root 2/2 as an x value, and that is for the angle measure. Here, sorry, didn't do this before. Our argument. That is for the angle measure of 3π/4. So that's one of our reference angles. Our second reference angle, looking again on this side where x is negative, where cosine is negative, down in this quadrant, we see that it is cosine is equal to negative square root 2/2 for 5π/4. So that's our second reference angle here. So that's what we're working with there. Those are our reference angles. We know that when cosine can equal negative square root 2/2 at either 3π/4 radians or 5π/4 radians. Those are our two values that we know from our unit circle. So moving on to step 3. I'm going to change paper here. There. Moving on to step 3. Step 3 is where we adjust our interval measures or values to match our angle denominators and our argument manipulation, I guess, whatever we're doing to our x value in our argument. So I'm going to copy down the interval that's given to us, which is 0 is less than or equal to x, which is less than or equal to 6π. And so to adjust for our denominators here, our angle measure denominators, we see that in this equation, the two reference angles that we got from our unit circle have a denominator of 4. So in the past two problems, we've been multiplying by 6/6. In this problem, we're going to be multiplying by 4/4 because that will give us values that have the same denominator as our reference angles. So that's easier to compare. So here, 0 times 4/4 is still 0. X times 4/4, 4x/4. And 6π times 4/4, 24π/4. So now you can see our reference angles here, oh, can I put those back in? There we go. Our reference angles here have the same denominators as our interval now, so we can compare those. So now we just have to account for the function that's taking place in our argument. So in this case, when we look at our argument is x minus 3 pi over 4. So as we did in the last problem, where we subtracted the same value from all three, that value in this problem is going to be 3 pi over 4. And remember we're subtracting that from all three values because we want to keep the equivalence of the values on either side of our equal signs, which in this case are less than or equal to signs. So we're going to keep all three sides of this equation equal by subtracting 3 pi over 4, because that's what we're doing to our argument. So I'm going to write over here, subtract 3 pi over 4. 0 minus 3 pi over 4 is going to give us negative 3 pi over 4. If we subtract 3 pi over 4 from our 4x over 4, 4x over 4 minus 3 pi over 4, which is, for our maximum value, 24 pi over 4. We're going to subtract 3 pi over 4 from that, and that's going to give us 21 pi over 4. And as I mentioned in the last video, I'm just going to keep kind of simplifying this value, which is really just getting rid of, again, the 4 over 4 value. So it's easier for the sake of comparison that it matches our original argument. So we're going to simplify our argument. So transfer this down. Again, we're just getting rid of those, simplifying the 4 over 4 fraction to equal 1. Bring down the, that's a subtraction sign. Negative 3 pi over 4. So less than or equal to 21 pi. Oh, I wrote 21 pi over pi. That is a 4. So this is our new interval that we're working with. So negative 3 pi over 4 is less than or equal to x minus 3 pi over 4, which is less than or equal to 21 pi over 4. That's what we're working with. And with that, move on to step 4, which is adding and subtracting our 2 pi value, our rotation around the unit circle, to find all of the values that fulfill our original equation within this interval. So I'm going to copy down the reference angles that we found. And x minus 3 pi over 4 is equal to 3 pi over 4. I'm going to box that because it's an angle. And we have x minus 3 pi over 4 is equal to 5 pi over 4. Okay, so in this problem, we're working with our 2 pi value that we're adding and subtracting is going to be written in a different form than in our previous problems, because again, we have a different denominator here. So in the previous problems, our 2 pi value has been represented by 12 pi over 6. But in this case, we're going to multiply to try to get 4 in the denominator so that it's easy to add our 2 pi value to our reference angle. So 2 pi times 4 gives us 8 pi, and 4 times 1 gives us 4. So this is going to be what we're adding to each of these values to represent our rotations clockwise and counterclockwise around our unit circle. So starting up here with the 3 pi over 4, I'm going to add 8 pi over 4, and 3 pi over 4 plus 8 pi over 4 is going to give us 11 pi over 4. We'll box that. And we see that that is still within our interval, so we're good. We can keep going. Add another 8 pi over 4. That's going to bring us to 19 pi over 4. I'll box that because it's an angle measure, and we're still good. For the sake of time on this video, I'm not going to keep adding because we can clearly see that if we were to add 8 pi over 4 to 19 pi over 4, we'd be getting 27 pi over 4, which is above our maximum interval limit. So we know that that's no good, so we can just kind of stop adding there because we know that's the maximum value that we can get to from this reference angle while staying within our intervals. So I'm going to take this over because we can see that we have a negative value here, so it's worth subtracting to kind of see if we can get any smaller than this value and stay within our interval. So if you subtract 8 pi over 4 from 3 pi over 4, you get negative 5 pi over 4, an angle measure. And when we compare that, we do see that that is it's too small. It's below our minimum value, so too low. So we can X that one out. And we know that subtracting any further would do us no good because we've already hit our minimum value. So moving on to our second reference angle, we can start by adding 8 pi over 4. So adding one rotation around our unit circle, and we get to 13 pi over 4. Check that, we're still good because it's less than 21 pi over 4. If we add another 8 pi over 4, that brings us right to 21 pi over 4. And again, this came up in the last video, but we're still good. That's still a reasonable answer because this is less than or equal to. So it can equal 21 pi over 4, and that's what we have here. So we're still good. But we know we can't get any bigger. So we're going to go on. Oop, don't want to copy that over. And again, we're going to subtract like we did up here to see if we can go any smaller than 5 pi over 4. So if we subtract our 2 pi value of 8 pi over 4 from 5 pi over 4, we're going to get negative 3 pi over 4, which if we check that with our interval, again, we found that we have, the minimum value of our interval is actually one of our answers. So that's also a viable solution for this problem because it's x just has to be greater than or equal to negative 3 pi over 4, and that's what we have. So we've identified 7 possible answers here, 7 possible solutions that we can now solve for x. Let's solve for x in step 5. So I'm going to copy down, keep bringing information into the next step. So again, for my sake, I'm going to copy these down in sequential order, lowest to largest, lowest to highest. So we have possible answers, negative 3 pi over 4. These are just commas, by the way, they're not ones, just to separate each of the answers so it's clear. Here we identified negative 3 pi over 4, 3 pi over 4, 5 pi over 4, 11 pi over 4, 13 pi over 4, 19 pi over 4, and 21 pi over 4 as possible answers here. So when you go to solve for x here, you're going to set your argument equal to each of these values. I'll show you for the first two, but then, it gets kind of repetitive after that, so, and you're doing the same thing. But for this first value of x minus 3 pi over 4 is equal to negative 3 pi over 4, so you're going to add 3 pi over 4 to either side. This cancels. Actually, so does this. So our first possible value, x equals 0 radians. So that's our first solution that we found. So we've done that one. Ooh, that's supposed to be a check mark. Okay, so our second possible solution that we found here is 3 pi over 4. So I'm going to write down our argument again, set it equal to 3 pi over 4, and then to solve, we're going to add 3 pi over 4 to either side. These cancel, and you're left with 3 pi over 4 plus 3 pi over 4, which gives you 6 pi over 4. Now this should be giving you kind of like bells and whistles again, alarms going off because it's not simplified. So when you simplify this, you can take a factor of 2 out of the numerator and denominator. So you're going to get x is equal to 3 pi over 2 as your final answer for that one. So if you keep going, doing the same process with each of these values where you set it equal to the argument, add 3 pi over 4 to both sides, and then simplify, your final answer set, solution set, should look like this. So these are all of your final solutions for what x can be in order for your original equation to be true. So x can be 0, can be 3 pi over 2, can be 2 pi, 7 pi over 2, 4 pi, 21 pi over 4, and 6 pi. So these 7 responses are just the simplified versions of all of these. So that's question number 3. Can move on to question number 4.